Hey, good morning, you guys. Just as an example of how to solve problems, quadratic word problems with projectiles. So let's just jump right into the problem. Here's a problem that says Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. So what I've done is on a separate piece of graph paper, I've written that down. And for each of our projectile motion problems, I'd like you to sketch a graph, write the model, write the function or the equation that you're going to be using, and then additionally, I would like you to have some sort of a t-chart down here that's listed either x and y, or in this case, t and h, t for time, h for height. That way I can see your multiple representations on one sheet of paper. So let's go back to the question. It says, how long did it take for Jason to reach his maximum height? So let's break down the formula. This negative 16t squared is the acceleration back towards the Earth due to gravity. So the negative, if you can kind of picture this path, Jason's going to jump off of this cliff and then come back to Earth, in this case to the water. And then this backside of this parabola is extraneous, meaning mathematically you can see that it's there, but doesn't exist in time. So as time goes on, he goes up and then back down. He's going to reach a maximum point. So that takes us to the first question. Remember, for the maximum height, how long does it take to get him to his maximum height? Well, we've been studying this maximum height right here is the vertex. Okay. In order to get the maximum or minimum, we're going to use x equals negative b over 2 times a, knowing that this is a, this is b, and this is c. So this, like I said before, negative 16t squared, negative 16 has to do with acceleration due to gravity. The middle term is his initial velocity, so he's going 16 feet per second when he starts to jump, or when he jumps. And then he's starting, poor Jason, at 480 feet from the sea level. So good luck, Jason. So staying with our problem here, I'm going to substitute the opposite of b, which is negative 16, over 2 times the a value, which is negative 16. And that's going to give me 1/2. So I know at 1/2 of a second, Jason's going to be at his maximum height. So 1/2 of a second, and that answers question A. So for question B, let's take a look at that. What was his highest point that Jason reached? Well, that's the y-coordinate that goes along with the vertex. So if I know that, part B wants to know what that height is. So I'm going to substitute h of t, but instead of t, I'm going to do h of 1/2 because I want to know what his height is after 1/2 of a second. So I'm going to substitute that in. Negative 16 is 1/2 squared plus 16 times 1/2 plus 480. So if I wanted to crunch that number with a calculator, it's pretty straightforward. What I'm going to do is negative 16 times 0.5 squared plus 16 times 0.5 plus 480. That's going to give me 484, which in this problem is his max height, 484 feet. So 484 feet. That's the answer to part B. Part C with this projectile problem says that Jason hit the water. Let's move this out of the way here. Jason hit the water after how many seconds? Okay. So now, if you look at the graph, you're assuming that he's going to come down here and hit the water. His height will be at 0. So if I put a 0 in for the height, leave the rest of the function identical, 0 equals negative 16t squared plus 16t plus 480. A couple of ways to solve this. One would be to take, and actually, let me shrink this down so you can see it a little bit better, even more so. One would be to take, so here's the same problem, and ask if there's a greatest common factor, in which this case there's negative 16 goes into all of those numbers. So if I factor out a negative 16, I get 0 equals negative 16 out in front. That becomes t squared. I'm dividing the coefficients by 16. So that becomes positive t. That becomes negative 1t. And then I believe this one becomes, let's see, greatest common factor here. It actually becomes 30, negative 30. So now I've got that factored out. And use the diamond problem. What are factors of the third term that add to the middle term? 6 and 5, negative 6. So 0 product property would say negative 16 is equal to t minus 6 times the quantity t plus 5. My solutions for t, there are two. One is 6 and one is negative 5. So that means when the y value is 0, I have one solution at 6. The other is at negative 5. So if I go back and look at my picture, that means that this is 6 seconds, 0 feet off the ground. This is negative 5 seconds and 0 feet off the ground. This part right here is extraneous, okay? Can't be a solution. Means mathematically it could work, but in the physical world it doesn't. Okay, one other way to solve this problem is to take the original function. So I guess the back up here for the solution is 6 seconds. Okay, and then the other way that you could solve this problem is by using the quadratic formula. We know, again, this is A, B, and C. Quadratic formula, x equals negative b, so negative 16 plus or minus the square root of b squared, right, which is 16 squared, minus 4 times a, which is negative 16, times c, which is 480. Let's get some big numbers here. All of this is over 2 times negative 16, or 2 times a. It's actually going to boil down to negative 16 plus or minus 176 over negative 32. One solution will be negative 5. All right, that's the positive solution. The negative solution will be positive 6, and we know this is extraneous. 6 seconds is my solution. So for each projectile problem, what I'm looking for from you all is for you to show a graph, show the equation, table of values, and then use whatever methods, whether whatever formula, if you decide to use a diamond problem and solve by factoring or quadratic formula, that flow needs to be there, and then the solutions kind of need to be pretty clear to make sure you're answering the questions. All right? All right. Thank you, guys. Good luck.